Welcome to Summarize Science. If you're a farmer with dozens of pigs that look nearly identical, how do you tell them apart for health checks or breeding records? Traditionally, you'd use methods like ear tags or microchips. But these methods have major drawbacks. Tags can get lost or damaged, microchips are costly and require an invasive procedure, and both can be impractical for small-scale farmers with limited resources. This paper proposes a brilliant solution. What if you could use something that's completely unique to each pig and can't ever be lost? I'm talking about the pattern of veins inside their ears. To test this, researchers collected 800 images from 20 different crossbreed pigs. They didn't need any fancy equipment. They just used a standard smartphone camera. By shining a simple flashlight behind the pig's ear, the tissue becomes translucent, making the complex network of veins clearly visible. Once they have the picture, a multi-stage computer vision pipeline takes over. First, the software automatically isolates the inner area of the ear. Then, it uses a series of image processing techniques to enhance the contrast and sharpen the image, making the dark vein patterns pop against the background. Here's where the real magic happens. The AI traces this vein network and analyzes its unique structure. It counts the number of branch points and end points, measures the distances and angles between them, and maps their overall density. All of this complex visual information is then converted into a unique list of 68 numbers, a digital fingerprint for that specific pig. To see how well these digital fingerprints worked, they were fed into 4 different machine learning models. The goal was to see which model could most accurately learn the patterns and correctly identify each of the 20 pigs from a new image. The results were outstanding. One model, a support vector machine, achieved an incredible 98.12% precision. This high level of accuracy is especially impressive because it was tested on a mixed population of different crossbreeds, which is much more challenging than working with a single, uniform breed. This chart, called a confusion matrix, gives us a great visual of that success. The strong, bright line running diagonally from top left to bottom right shows that for almost every test image, the AI's predicted pig ID perfectly matched the actual pig ID. The very few colored squares off the diagonal represent the rare instances where it got confused between 2 individuals with similar vein patterns. But is it practical for a busy farm? Absolutely. The entire pipeline, from capturing the image to getting a final identification, takes an average of just 8.3 seconds on a smartphone. This speed makes it perfectly feasible for real-time use in the field. So, let's quickly recap what makes this system so special. Researchers created a method that uses a smartphone and a simple light to capture a pig's unique ear vein pattern. An AI then processes this image, creates a 68-point digital fingerprint, and uses it to identify the pig with over 98% accuracy, all in under 10 seconds. The implications here are enormous. This provides a low-cost, non-invasive, and highly accurate identification method for small-scale farmers who are vital to our global food supply. It democratizes precision farming technology, allowing for better health monitoring, optimized breeding, and improved animal welfare without expensive equipment. The future of farming could involve integrating this with other biometrics or even using it to detect early signs of illness. Thanks for watching Summarize Science.